In this video, we are going to use the TI-83 calculator to compute the value of R, the line of best fit, which is also called the least squares regression line, value of R squared, and to graph the scatter plot of bivariate data. The data that we are using is the number of floors and the corresponding heights of the tallest 10 buildings in Cincinnati. Our explanatory variable is going to be the number of floors. Our response variable is going to be the height. Let's start with the scatter plot. First thing that we need to do is we need to input this data into a list. Normally, you'll want your explanatory variable to be in list 1 and your response variable in list 2. To put the data in a list, we go to Stat. It's on Edit, so we hit Enter. List 1 will be the number of floors. List 2 will be the heights. Once the data has been put into the list, we now go to Stat Plot, which is second and y equals. Then we hit Enter. We first have to turn the plot on. We hit Enter. The default is a scatter plot, and that's what we want. The X list should be list 1. The Y list should be list 2. And I like to use the default for the mark for each data point. Now that we have the stat plot turned on, let's go back to the home screen, which is second, and mode, which is quit. Now in order to graph the scatter plot, we want to let the calculator determine the corresponding scale for the x-axis and the y-axis, and we do that by using the zoom. So we hit zoom, and we're going to look for zoom stat, which is number 9. And here we have our data. This is our scatter plot. So the x-axis is the number of floors, the y-axis is the corresponding height. So according to the scatter plot, there appears to be a positive linear relationship between the two. There is a way to quantify this, and that's by using R, Pearson's correlation coefficient. To compute R, we have to turn the diagnostics on. Now to do this, and you only have to do this once, let's go back to the home screen. To find the value of R, we need to turn on the diagnostic, and the way you do that is you use the catalog feature, which is second and 0, and we're going to look for the D's. And here we see a diagnostic on. We hit Enter and Enter again. So now we can find the value of R. The way we do that is we go back to Stat, using our right arrow key, calculate, and then we want number 4, the linear regression. So this is the least squares regression line, or the line of best fit. Our X list is list 1. The Y list is list 2. And then we hit calculate. Here we see that A is our slope, B, our y-intercept, is 37.9. Here is R square, and here is the value of R. This is Pearson's correlation coefficient. So we would say, based upon this value and the scatter plot, there is a strong positive linear correlation between the two variables. Now R squared is what we call the coefficient of determination, and what this tells us the proportion of variation and the y variable, heights, that's explained by the model, the line. So if we were to express this as a percent, we would say about 67% of the variation and the heights is explained by the line. Now if we would want to graph this line of best fit with the scatter plot, we go to y equals. We need to paste in the line of best fit. So one way is you could just write the equation down and then type it in. Another way is to use the calculator's memory. So if we go to variables, go down to number 5, which is statistics, move it to equations, EQ, and the very first one is linear regression, number 1. Now this pastes the line of best fit into Y1. We hit graph, and we see the line of best fit with the scatter plot. This concludes this video. Thanks for watching.